So let's talk about a language that is quite literally running the digital world. It's behind almost every app on your phone, every website you visit, from your banking to your social media feed. It's called SQL, and it's the universal way we talk to data. Let's dive in.
Here's how we're going to break it down. We'll start with a problem you've probably faced with spreadsheets. Then, we'll build up our understanding step by step, imagining our data as a digital filing cabinet. We'll lay down some important rules, connect all the pieces, and then, the fun part, we'll write our very first SQL command together. All right, let's kick things off with Section 1, the spreadsheet problem. Look, we all start with spreadsheets. They're simple, they're familiar, but they have a breaking point. And when they break hard, especially as things start to grow.
Think about it. A spreadsheet is perfect for your personal budget, right? Or a small list of tasks. But what happens when you're trying to manage an entire online store? We're talking thousands of customers, maybe millions of orders. That spreadsheet just grinds to a halt. It gets slow, it's clunky, and trying to find one specific piece of information feels impossible. So let's really put them side by side. On the left, you've got spreadsheets. Great for small, manual stuff. But they're super prone to errors. We've all made a copy-paste mistake, right? That's what we call low data integrity. But on the right, you have databases. These things are built to handle massive, massive amounts of data. They allow for automation, and this is key, they enforce rules to keep your data accurate. That gives you high integrity. The bottom line is, when your data grows up, it needs a more powerful home, and that home is a database.
So, what in the world is a database anyway? Let's forget about code for just a minute and think about it with a really simple analogy, a digital filing cabinet. At its core, that's all a database is. It's a container, a super organized system designed to store and manage all of your information. But just like a real filing system, the real power isn't the cabinet itself. It's how everything is structured on the inside. So, inside that big cabinet, we have folders. In the database world, we just call these tables. You'd have one table just for students and a totally separate one for products. Each table holds one and only one specific kind of information. See? Pretty simple, right? Okay, now let's open one of those folders. Inside, you'd have pages with predefined categories, like little boxes you need to fill in. Those are your columns. So for our students table, the columns would be name, age, city. They're like the template that defines every piece of information we want to keep for every single student. And finally, what do we actually write on those pages? The data itself. Each complete entry, all the info for one specific student, is called a row. So a row is one complete record. Put it all together, and a table is just a big collection of rows, all neatly organized by the columns we defined. Now, we have our digital filing cabinet all set up, but if we're not careful, it can get messy fast. We need to prevent that chaos. And that brings us to Section 3, setting the rules. This is where a database really starts to shine. The most basic, most fundamental rule is something called a data type. This is where you tell each column exactly what kind of information it's allowed to hold. Is it a number? Is it text? A date? This simple rule prevents so many errors and keeps all of your data consistent and clean. Here are some of the most common ones you'll see all the time. INT is for integers, whole numbers. Varchar is for variable characters, which is just a fancy way of saying text, like a name or a city. Date is, well, it's for dates. Float is for numbers that have decimal points, and bool is for simple true or false values. By setting these rules up front, you guarantee your data stays reliable. Okay, so quick check for understanding. You need to store a student's name in your table. Looking at that list, which data type are you going to pick? If you said varchar, you are absolutely right. It's the perfect tool for the job. So we have these perfectly organized folders full of clean, reliable data. That's great, but right now, they're all separate. The real magic, the real power of a database happens when we start linking those folders together. And that's our focus in Section 4, connecting the dots. Think about it like this. It's a perfect analogy. In any classroom, you could easily have two students named Ravi. So how does the teacher tell them apart? With a unique roll number, right? No two students can ever share the same one. This simple idea is absolutely critical to how databases work. In SQL, that unique roll number has a special name. It's called a primary key. It's a special column where every single value has to be unique. It acts as the official, undeniable ID for each row in your table. This makes sure you can always find the exact record you're looking for, and it makes duplicates impossible. So, how do we link our tables? With a foreign key. This is so cool. Imagine you have your students table and a separate courses table. To show which student is taking which course, you just take the primary key from the students table, that unique student ID, and you put it in a column in the courses table. That student ID, when it's in the courses table, is now a foreign key. It's a bridge, a pointer, that creates a clear relationship between a student and their courses.
Okay, enough theory. Let's get our hands dirty and see what this all looks like in practice. This is section 5, your first command. All right, let's walk through a real SQL command. Don't let it intimidate you. It's actually pretty logical. First, we just say create table student, which is exactly what it sounds like. Then we start defining our columns. First is student ID. We say its data type is int, and here's the important part. We declare it as our primary key. That's our unique identifier. Next, the name column. We set its type to varchar for text, and we add another rule, not null. That just means this field can't be left empty. Every student has to have a name. Then we add age as an integer and city as more text. Finally, we close it all up. And just like that, we've told the database exactly how to build our student table.
And you know what? Almost everything you'll ever do with data boils down to 4 basic actions. There's a handy acronym for it, CRUD. We just did the C. We created a table structure. The others are R for read, which is how you look at data, U for update, to make changes, and D for delete. Pretty much every command falls into one of these categories. So with just a handful of simple, almost English-like commands built on these ideas of tables, columns, and keys, you suddenly have the power to manage, search, and change millions, even billions of records in the blink of an eye. That right there is the incredible power of SQL. So we'll end with this challenge for you. You've built your student table. Awesome. But what if your boss comes to you and says, hey, we need to start tracking each student's grade? How would you add a new grade column to the table you already made? Well, the answer lies in your next step, a command called alter. And that's the real beauty of SQL. It's designed to grow and change right along with your needs.